Welcome back to my channel. This is Arshita and we're studying in Sri Venkateshwara College of Engineering, and today's topic is two-port parameters. Introduction to two-port parameters. Two-port network are fundamental in electrical engineering. They allow for analysis of complex circuits in simplified manner. This presentation will cover the different types of two-port parameters with an example application. Definition of two-port network. A two-port network has two pairs of terminals for inputs and outputs. It can be represented using various parameters like Z, Y, H, and ABCD parameters. These parameters help in characterizing the behavior of electrical network. Importance of two-port parameters. Two-port parameters simplify the analysis of linear electrical networks. They facilitate the interconnection of multiple two-port network. Understanding these parameters is crucial for circuit design and analysis. Z parameter, impedance parameter. Z parameter relate voltage and current at the ports using impedance. They are defined as V1 is equals to Z11 I1 plus Z12 I2, and V2 is equals to Z21 I1 plus Z22 I2. Z parameters are particularly useful for circuits with known input and output impedances. Y parameters are admittance parameter describes the relationship between the current and voltage using admittance. There are represented as I1 is equals to Y11 and V1 plus y12 into v2 plus, and I2 is equals to y21 v1 plus y22 v2. Y parameters are are the advantages when dealing with parallel circuits. H parameters are hybrid parameters, combine voltage and current relationships in hybrid form. They are expressed as V1 is equals to H11 I1 plus H12 V2, and I2 is equals to H21 I1 plus H22 V2. H parameters are often used in high frequency applications like RF amplifier. Various two-port parameters can be converted from one type to another. Each parameter set as its advantages depending on the application. Understanding these relationships is key to effective circuit analysis. Example of two-port network. Consider a simple resistor network with R1 and R2 as two resistors. We calculate the Z parameter for this network. This example will illustrate how to derive the parameters from the physical circuit. Deriving Z parameters for example network. For the example with R1 and R2, we find Z11 is equals to R1 and Z22 is equals to R2. Z12 and Z21 can be calculated based on the network configuration. This gives us a complete Z parameter representation for the network. Application of Z parameters. Z parameters can be used to analyze the input impedance of the network. They also help in determining the output voltage for given input current. This is crucial in designing circuits with a specific performance criteria. Example for Y parameter. We can also derive Y parameter for the same resistor network. For example, Y11 is equals to 1 by R1, now Y22 is equals to 1 by R2. This allows us to analyze the circuit response of the network to the applied voltages. Practical applications of two-port parameters. Two-port parameters are widely used in RF design and telecommunication circuits. They assist in design of amplifiers, filters, and oscillators. Their ability to model complex interactions makes them invaluable in engineering. So the summary of this key points: two-port network provide a systematic way to analyze electrical networks. ZYH, and ABCD parameters each have a unique applications and advantages. Understanding these parameters is essential for effective circuit design and analysis. Thank you.